mode to the batteries and run your vehicle to the battery on battery. And similar goes with the fuel cells. Fuel cells are currently not that much equipped in electric vehicle sectors because they are still in the researching phase. They have not commercialized it since fuel cells uses hydrogen as their prime fuel. The major disadvantage when considering fuel cell is that the transportation of the hydrogen, because as everyone know, hydrogen is the most flammable thing, and we cannot transmit it that easily. As much easy we can transmit the fuels from using the pipelines and trucks and tankers, all those things. That's the main reason that fuel cells are not currently equipped. But yes, in the future we can think that the fuel cells will definitely be kicking in the electric vehicle markets, and it will change the whole scenario for the electric vehicles kind of market of the electric vehicles. Am I audible, sir?
Yes, Kaustubh,
Yes,
you're audible properly.
Yeah.
yes, sir. You are audible.
Just a second. Change the settings.
Okay.
Is it visible now?
Yes, Kaustubh.
So when we think electric vehicle, the first question everyone in the society will be considering why we should go for an electric vehicle instead of going on the vehicles, because day by day as we are hearing all the news from the paper or news channels that our earth is getting polluting because of the all the fumes and the emissions from our IC engines, silencers or mufflers, which all are driving currently. That's the biggest reason for considering an electric vehicles. Another biggest reason is that the price of the fuel is day by day increasing, as it is a fossil fuels which will surely be depleting from the earth's core, and we will not be able to run our vehicles on the fuels. So considering an alternating solution for the vehicles to be run, electric vehicles have to be considered. And let me remind you, electric vehicle is not uh, the latest in technology. It is the oldest technology which we all have. The first electric vehicle is introduced in 1912. So it's not an something which is developing now. It has already developed in the past, and we haven't continued using it. That is the main reason everyone is not that much aware about an electric vehicle, because in the older days the motors were not that much powerful and they cannot give you that much of range. So people were trying to shift from electric vehicles to the fuel vehicles, because in the fuel vehicles you don't have to think about the limitations of the kilometers to which you can travel. You can just go to any fuel station, pump in all the fuels you're needing, and keep on running on the roads. That easy is the fuel vehicles. Whereas the hassle comes in electric vehicles is that you have to keep on thinking that how much charge is left inside my battery. So that is the one reason we have to consider. And something from the battery background, I can tell you that the range for the customers are way more important than costing of it. Okay, so EV is a road vehicle based on a modern electric propulsion consisting of an electric machines, power electronics converters, electric energy sources, and storage devices, and electronic controllers. So electric vehicle basically consisting of the 4 or 5 components, which your IC engine vehicle will also be having. The major difference in between the IC engine and the electric vehicle is that they uses completely different powertrain. In IC engines, you will be having an engine, differential, gearbox. What else you can have is the propeller shaft, radiator. Radiator we also use it in the electric vehicles. It's not that much difference, but yes, this all those things can reduce the weight of the vehicles. And while reducing the weight of the vehicles, we can expect the more range from the vehicles. As okay, let's not go into those things. So EV is a broad concept including battery electric vehicle, hybrid electric vehicle, fuel cell electric vehicle, etc. In regenerative braking is also possible in the electric vehicles. So what is regenerative braking? We'll see definitely in the next couple of the slides. But I'll give you a short note about what is exactly a regenerative braking. So let's assume you are driving a vehicle and instantly you don't feel to throttle your vehicle anymore. So for an example, if you're going down the hills, we usually don't press more throttle when we are going down to the hill or any slope like roads. So at that moment, if you release your feet from throttles, the regenerative braking in the motor will kick in, and the energy from your wheels to the batteries will get converted reversely, and the charges of your battery get increased. So this concept is currently in the not that much developed. It is still developing, but it will gives you an couple of the more kilometers when we are expecting an electric vehicle. The most advanced regenerative braking currently is that you can almost generate 70% of an energy from your wheels. Okay. Okay, please keep on telling me that you guys are listening to me. Otherwise, I'll be thinking that I'm only speaking. Okay. Hello. Hello. Am I audible, guys?
Yes, sir.
Yes, sir.
So keep on interacting, guys. If anyone is having any doubts, feel free to ask anytime. You don't have to think that I might be getting interrupted. I will love to get interrupted by your guys' questions from your side. Okay. Shall I continue?
Yes, sir.
Yes, sir.
So electric vehicle is an intelligent system. It has its own intelligence. Nowadays, we are also. I think everyone must have heard about the Morris Garage's AI inside concepts. Hey everyone, turn on your mics actually. It will be more good for us. Hello. Hello. Hey Mohan, Tejas, Abhijit.
Yes, sir.
Yes, sir.
And don't call me sir, yeah, I'm not that much expert. It's okay, you can call me Kaustuv also. Just keep your mics on. I don't mind anything. बोर हो रहा है क्या गाइस?
No, sir. No, sir.
No, sir.
नहीं हो रहा हो तो बोलो, मैं थोड़ा अलग वे में एक्सप्लेन करता हूँ अगर आप लोगों को हो रहा हो तो.
No, sir.
Who is the CR of your class? Hello?
Actually, we are from different divisions.
Oh, and in what year you guys are? Third year, final year?
Uh, Third year, TY.
Okay. And Sanjuni College, right?
Yes.
Yes, sir.
Okay. Should I keep it like this? You all can see the screens?
Yes, sir. No issue.
Yeah. So EV is currently not that much developed in India. It is basically a technology which we have borrowed from China. As Chinese market has been evolved for at least 20 years back. They have considered electric vehicles before 20 years, and they have done beautifully all the developments and technology evaluations contribution to our electric vehicle sectors or electric vehicle categories of the vehicles. They are marvelous in their designs. So we are also developing in EV, as everyone must have heard about the Tata Nexon, which is giving an immense amount of the boom to the electric vehicle domain. And there are another electric vehicles when we consider. Tesla is the role model for everyone. Everyone is going crazy when they are thinking about the Tesla. That Tesla is having scissor doors. It can drive at its own. It is having an autonomous vehicles of a level 5. All those things given as an Elon Musk and the Tesla are nice and most developing market conveyors to the electric vehicle sectors. Okay, before going or wasting another time, we'll shift to the next slide. So these are the basic components any vehicle or any electric vehicle will be having. So the major portions will be covering from an auxiliary powers, that is your batteries, energy sources, propulsion systems are your motors, and we all knows what wheels are used for. So the electric propulsion system generates the powers necessary to the wheels. In electric vehicles, there is the controller which gives a signal to your motor that how much amount of an energy the user is requesting you to deliver to the wheels. In energy storage sectors, we call this as an wheel to well concept. Okay, or wheel to wheel concept. It's bipolar in both the directions. We can go eitherly from the wheels to the vehicle also, as I told you about regenerative braking, and similar thingly it goes from wheel to the wheels, that is from battery to the wheels, that power will be delivered. Okay, so the energy sources might get changes in vehicles, that is fossil fuels, battery or fuel cells, and it defines the class of the vehicles. Auxiliary power such as your air conditioning systems, your telematics controller, and other things, your sunroof, all those electronics accessories are considered as an auxiliary power consuming device. Okay. So, basic of an electrical drives, in simple words, the system which controls the motion of an electric machine is known as electrical drives. It is nothing different from when we consider as an IC engine. Electric vehicle only consists of an motor instead of an engine. Okay, and the electrical energy get converted into the rotating motions of your wheels. That's how your vehicles get propelled, and it is known as an electrical drive. A typical drive system is assembled with an electric motor, maybe a several. That means there may be a couple of more motors. Either I can connect one motor to the complete vehicles, or if I am considering a car or any big segments vehicles, then I can connect a motor to each vehicle, each wheel. So this is known as the series motors. We can connect all those motors into the series, and the motors will deliver the power more rapidly instead of considering a single motor or two motors. Okay, but the major portion when considering the series motor is that you have to design the controller part very precisely, and the circuitry gets more complex when we are thinking about the more numbers of the motors. But yeah, it can be doable. It is not that much difficult. We can do those things. Okay, there are a couple of the examples in which electric motors or electric drives are successfully being implemented. The basic example of an electric motor is our fans, which we use at our homes. Another are like the factories, transportation systems, pumping motors, robots, etc. Okay. So the drives are employed as a prime movers for diesel and petrol engine, gas or steam turbines, hydraulic motors, and electric motors. Okay. This is the drive system component. The first thing goes is the source from where you are expecting to get the energy to turning your wheels. Next one is the power module. Because we cannot use the motor directly to power our wheels, we have to do some more modulations into the power delivered by the vehicles or the delivered by the batteries to our motor, because motor works quite a different. It needs a certain bandwidth in which the power is getting delivered. So that's how a motor will run. And your load is nothing but the wheels. And this is a feedback system which is used in order to establish more and more precise modulation to your powers and with less numbers of an errors. We are using this as a feedback system. So the sensing units are there to identify if there are any difference in the process which is going. So those things will sense and it will give an idea to the control unit, or which we call it as a bit of a data to the control unit, and controller unit will change the modulation of the power again, so that the motor will run smoothly and the consumer or the driver feels less of the jerks and gives him a quite a good experience while driving their vehicles. Okay, anyone here having any questions?
No, sir.
Okay. So this is in more detail. I have represented the sources of components of the drive system. The source is the electrical source. That is the your battery will be considered as the source in this part. Power modular, as I told you, that power electronics part is used for conversion of the electrical power, which is to be used for driving the wheels. In the motor, we can have DC motor, induction motor. Special purpose motors means that we can connect induction motor or DC motor together also. That is known as the series DC motors, which we can use for driving the heavier side of the vehicle. Have you seen that PNPL green bus, which we all have we must have traveled sometimes in our life in the Pune? Anyone?
Yes, sir.
Yeah, so that type of the vehicle is the heavier class of the vehicles, which uses the special purposes motors, which has been implemented in. And if I'm not wrong, it uses 120 volts, 800 Ah of a battery pack. So it gives them a very nice amount of a range and with a good ample amount of the power when considered as the voltage gives the power to the motors, and the more AH you increase, that is the more capacity you increase, the range of the vehicles get increased. So that is the basic logic behind designing the motor and the electric vehicle concepts. Load is the mechanical load on EV considering on road approach. That is your bumpings, your the speed breakers. You need to throttle your vehicles into the upper direction of the bridge or going the downward side of the bridge. That we can consider into the load. And sensing units, all we can know that the speed sensor, torque sensor, rotary motion sensor, controller unit is an any embedded control. So I'll share this link with you all. This is actually a good PDF which you can all read if you think about anything into the motor. So I'll paste it into the chat box. This is an IJESC society which they have given as what type of motors to be selected. It's actually a motor selection process which they have identified as a basic idea for how exactly a motor is to be used for an electric vehicle. Okay. So this is an basic electric vehicle structures which shows that this will be the charging point. Batteries will be stored in the bottom of the vehicle or in the below of the vehicles. The drivetrain is connected over here. What difference do you guys feel is that when we consider an electric vehicle and IC engine? Come on, tell me fast. Anyone? Hello.
Yes, sir.
So who said yes now? Mohan. Mohan, I guess. Well, the basic difference when considering motor, electric vehicles and IC engine is that your motors are not fitted into the bonnet. So that is the biggest difference you can get. It is shown into that, but it is not fitted into that. But some of the vehicles are thinking like that we can have the more boot space. So when Tesla, if anyone has seen Tesla, they must have known that the boot space into the Tesla is way bigger. And their pitching skills is like that you are getting the more boot space into the vehicles. You can store more storage into the front of the area and the back side of the area also. So basically, the electric motors are attached to your wheels, or there is a drivetrain which will be attaching all those links to the each other and delivering the power to the wheels. So let's go back to the motor part. This is a typical motor which everyone must have seen in their homes for delivering the power from the well or boring wells if you have. So it's nothing more different from that motor to our vehicle's motor. It consisting of a frame, stator windings. The winding will be connected into this particular position, and there is certain air gaps provided to reduce the heating from the rotation of the shaft, and the commutator is used. We'll go into the details of all these things into the next slides. Just take a look over it and tell me if you have anything to ask. I'll be back in a second. Just go through that image. Sorry for that. I hope everyone must have at least read the names of the components of the motor. So, electric motor functions on the Fleming's left-hand rule. Fleming has given us this angle of degrees through which we can identify in which direction what force is acting. Let's go by the Fleming's left-hand rule. It states that if we stretch the thumb, middle finger, and index finger of the left hand in such a way, which is shown in this figure, that all three fingers are making a perpendicular angle with each other. That is the difference of a 90 degree with all the three fingers. We can identify the direction of the force exerting onto the coil of the motor, the direction of the magnetic field, and the current which is driving the vehicle, driving the motor. Sorry, not vehicle, motor. Okay, so let's move ahead. So this is a basic model how exactly the motor runs. As you can see, everyone must have known that the magnetic field always flows from north pole to the south pole. So when the motor magnetic fields are traveling from north pole to the south pole, we can see these arrows. This arrow depicts that the magnetic field is going in this direction. That is from north pole to the south pole. We can see in this diagram. Okay. So for an example, I have considered this as a electric coil of your motor. It consisting of a rectangular shape because it is much more easier to understand uh, instead of considering any other one. So let's move on. Okay. So when we think about the Fleming's left-hand rule, that is the thumb is showing you the force. That is when I consider the pink color of the coil, pink side of the soil coil. The force is acting in the upward direction. My magnetic fields are in this direction. Okay, and the current will be flowing in the inside direction. That is from the battery. I have to connect this to the battery or any other power sources like this. If I am connecting this and completing the circuit, the current will start flowing in this direction. Okay, that's the main reason these arrows are showing. That's the reason these arrows are showing how the circuit is flowing. Due to this Fleming's left hand rule, I can consider. Okay, let's go from here. This is the magnetic field, direction of magnetic field. This is the direction of the force your coil will be experiencing, and this is the direction of the current flowing inside your motor. As a result of this, the coil will experience the upward lift, okay, from pink side. And when we consider the blue side, it goes into the reverse direction. The direction of the force is into the downward direction. The current is flowing outside of your motor, and this is the field of magnetization. So this will be delivering the downward force on the blue side of the motor. As a result of which, your motor will or your coil will start rotating in such a way that the pink side will experience a pull and it will try to move in upward direction, whereas the blue side of your coil is experiencing a push. That's why the motor is or the coil is turned into the clockwise direction. But when we think in such a way that right now this pink side has come here, now my motor is facing the downward force on the left side. That is my blue. Okay. So everyone must be thinking why now what will be the reason how the motor will be running. From this point of view, I can see that the motor is experiencing this. So I can say this is not a good motor, right? As it is not going to complete its single rotation also. So how are we going to do those things? We can do those things either by changing the direction of magnets or magnetic field, or either by reversing the current. That is, if I give negative connection to this side now and positive connection to this side, this can be done. But in the real world, we are not able to do those things because electric motors runs on the at least 3000 rpms, or it can also reduce to the certain levels. But when we are considering vehicles, 3000 rpm is the lowest which we can achieve. Okay, so for which we can use this couple of discs. It is known as commutator. Okay, it is divided into two different parts. It is also known as split rings, which are connected with this. This is known as the brushes. The brushes are making a sliding contact with each other. Either means the brush is sliding on the split ring. As a result, when this pink portion is connected to this side, that is the positive direction, positive current will flow. And when the negative connection is connected to this blue, that means my circuit is completed and the current will start flowing in this direction. As a result, when the pink is connected to the positive of this brush, the motor will turn its 180-degree rotation. Okay. So when and similarly when the after completing the rotation, the split ring will turn its sides and blue will connect it to this brush. Okay, and the direction of the current or the polarity of the current get changes. That is, the positive is now connected to the blue side. As a result, the motor will face the upward force from the blue and downward force from the pink. And this motion gives you the complete rotation for the motor. So that's how your motor works, basically. Okay, shall I move ahead? Hello.
Yes, sir.
Thank you, whoever it is. So this is
I
the class.
appreciate. Hello, sir. This is Professor Joshi. I appreciate students to be attentive, and whenever the speaker asks for your question, you need to answer. Okay.
Hello.
Yes, sir. You can continue. Thank you.
Can you repeat, sir? Actually, there was some hammering sound from your background. So
Yes, yes, yes. Sorry, I'm in midst of something. You can continue, sir. Thank you.
Yeah. Okay. Okay. Thank you, Jyoti. So this is the basically classifications of the electric motors. It is basically divided into DC motor, induction motor, synchronous motor, and electronically commuted motor. Okay, the DC motor is again further divided, which I have not shown here because it will create a much more confusion if we go into the more details. So, induction motors is having two different types, that is squirrel cage motors and the wound rotor. Uh, Squirrel cage motor, the name came from that is that it exactly replicates how a cage of a squirrel or a cage of the bird is designed. This motor is similarly designed in such a way. Okay, that's the name. It has the squirrel cage rotor. Wound rotor is that the coils of your motor gets wound around the rotors. Okay. Synchronous motors are having another three different types, that is rotor excited, permanent magnet, reluctance motors. Nowadays, permanent magnet and reluctance motors are getting combined with each other. Okay. So they can the makers and the manufacturers have done these works that they can combine the performance of the both motors and deliver the good amount when considering, because the problems with the reluctance motor is that it does not deliver that much of a power, but it has a very good type rotor constructions. And when we consider the permanent magnets, the life of the permanent magnet motors is very high. We can expect almost 98% of an efficiency from permanent magnet synchronous motors or permanent magnet reluctance motors. Okay. The another type of the motor is that brushless DC motor. That is the BLDC motors, which every electrical or every EV engineer must have gone through this concept. That is the BLDC motors, because all the two wheelers and three wheelers uses BLDC motors because it is much more cheap. You can expect almost 95% of an efficiency from BLDC, and this is not that much complex to construct. It has a good torque delivery ability at lower speed also. We'll see it more in details in the next slides. Okay. So its reluctance motor is similar to the BLDC motor. Just like I explained here, the commutator will be used to switch the polarity. It is similar way that the switch reluctance motors also work. Okay. So this is an AC motor, which which we don't use, but it gives an idea how exactly an AC motor works. Electric vehicles don't use an AC motors because the power delivery from the AC motor goes on decreasing with the certain periods of cycles when we consider. This is exactly the same which I have explained in the previous slides, that when the commutator changes its positions or the split ring changes its position, the polarity of the current flowing into this particular direction changes. It is going much more fast. That's why I have incorporated those images for understanding of you guys. Okay, so from this portion we can see that the coil is rotating in clockwise direction whenever my current is changing its polarity. AC drives are also known as variable frequency drives. It cannot be considered as the constant delivering power substance, or the you cannot expect it to deliver the constant power to your vehicles. That's why AC drives are not considered into an electric vehicles. The most important part of an AC motor are stators and the rotor. Okay, DC motor. DC motor is a machine that transforms electrical energy into mechanical energy in form of rotation. Its movement is produced by physical behavior of electromagnetization. This is also considered as an DC motors application also. Just we have to change this commutator to the slip rings, whereas this is the split rings. And I'll show it here. This is much more rigidly showing. So this is the outside of this is your, you can say this is a steel yoke it is representing, but it is much more like a casing in which your stator is there,
Hello,
and the stator are,
sorry to interrupt, Kaustup. You are presenting 14 number slide.
just a minute. Yeah.
Okay, okay.
No, actually I'm on 16 numbers slide.
Okay, so there was a delay. We were on 14 number of slide.
Okay. So that's why I asked people to keep on reminding these things, because when we are presenting now, we don't get an idea what exactly we are presenting to the others. So please keep on repeating these things, because I am also facing a certain connectivity issues. Okay, is this screen visible to everyone?
Yes, yes. 16th, yeah.
Yes,
Major
sir.
components
Yes,
of
yes.
DC motor.
Yeah, yeah. Okay. Sorry for that. Okay. So when we consider this blue portion, it is nothing but your rotor. It consisting of the windings, and these are the magnets. Similar to this. Similarly, these are arranged here in the same way. Okay. Have you seen this? North pole, south pole. Hey, Harshal.
Yes, yes, yes.
Yeah.
There is no delay now. Yeah.
Yeah, yeah. Okay. So in this direction, when the rotor rotates, it faces the certain, similarly that only the forces of the magnetics and the direction of magnetism changes, and sorry, the direction of the polarity changes, and it gives the rotation to this rotor, and by rotating this rotor we only get the powers. This is the similar concept goes with the electric generators also. Okay, so uh, I don't know what type of an electric service is in the Pune. I guess this is MSCB only. So MSCB is also using this type of the rotors for generating the electricity which we are currently using. It can be rotated either with, so generator has to be rotated externally, whereas motors produces the rotation for that generator. Okay, this is the difference between electric motor and the generator. So when we give the magnetic force to this, the rotors will rotate and it will give the power to your shaft. That's how the wheels will rotate. Whereas in the motor, this goes opposite direction. You can give rotation to this rotor either by using steam, that is exactly happening in the steam turbines. And when we consider nuclear energy, also the amount of a nuclear energy gives the magnetism or the rotation to this. Not that much aware about nuclear power, but it functions similarly in this also only, because you only have also hydraulic power is similar to the this construction also. When we allow the water to rotate or allow the water to exert of the force, I think everyone must have heard about the hydraulic powers, right? Being a mechanical background, everyone, right?
Yes, sir. We have heard about it.
Yeah, yeah. So this is nothing but the similar to the hydraulic turbines only. The one which you must have heard, that a Pelton wheel turbine, Kaplan turbine. This is similar to that only. Only thing is that you have to consider the magnets instead of the water. Okay. So what we do in the hydraulic turbine is that we allow the water to flow from upper end to the lower end with a, which gives it the more velocity, and that water is injected with the help of the nozzles, right? So same thing goes here. The North Pole and the South Pole exerts the similar amount of the forces which the water is exerting on the rotor of the Pelton wheel. Only difference is that it is doing much more easily without creating much more of a hassle to the users. That's why electric motors are very well considered into the industry, and it is having the ample amount of an application purposes usage into the industry. Okay, so you can read this, the stator. I'll share this PPT with you all also, so that you can use it in for your reference. I'll mail it to the Harshal. Harshal, you can mail it to the sir who is coordinating with us, right?
Yeah.
Yeah. Okay, so let's move ahead. This is the different types of the components of the DC motors which I have enlisted here. You all can read into the like that. Field winding is an exciting system which may be electrical winding on permanent magnet which is located on the stator. So this is your stator. You see these poles. Okay, later. This is your field winding, which is wrapped around the magnets of all those things. Okay, so what exactly happens is that the more amount of the winding is there, the more amount of your smoothness of the working of your motor gets increased, or it will also be considered as delivering the more power to your vehicles or your motors. Sorry. DC motors are classified how their armature and field windings are connected to their DC power supply. Commutator is nothing but this portion, which I have already told you what exactly is commutator. Okay, so if there is a delay, you all can see.
Kaustubh, are you
Yeah,
on second 16th number of slide?
yeah. I'm switching from 16 and 14 number of slides. That's why I
Yeah,
stayed over there for certain period of time.
yeah. We are on 16th only. We didn't
Yeah,
shift
yeah.
yet to 14.
Yeah, okay. So this is the 14 number of slide. This is the commutator, which I was telling exactly. Okay. Shall I move?
Yes, yes.
Yeah. Right. So these are the brushes which are kept in contact with your these portions to change the polarity of the currents every time it keeps on rotating. That's why the brushes are used.
Kaustubh, have you changed the slide?
Yeah, I have changed to the 16th one.
No,
Okay, okay.
it is right now on a 16th only.
Yeah, it is on 16th.
Yeah.
Okay, not an issue.
Okay. These are the brushes which I told. The poles. The field winding is placed in the poles. As I already told you, the field winding is connected into the poles. The more number of the poles increase, the more amount of the power this motor will be generating, and it will be performing smoothly also. Motor housing is similar to the casing in which you are enclosed all the important components of your vehicle. It is not that much important. So this is the working of the DC motor. It is similar to the AC only. The only difference is that here is the split ring. There was a commutator. Okay. Or else here we can do is that we can also arrange the another commutator here and allow the one wire to be connected in these directions and the another wire gets connected into this brush. So this is the only difference with the DC motors and the AC motor. Another difference is that DC motor produces much of an iron losses, but it is not that much affecting the performance of the motor. So we can neglect those things while considering a motor for your electric vehicles. AC motor whereas does not perform well after certain periods of time, as I already told. That's why DC motors are much more preferred into the AC motors. So, commonly used motors for electric vehicles are brushless DC motor, permanent magnet synchronous motors, interior permanent magnet motor, AC induction motor. Okay. So the difference between the permanent magnet and the interior permanent magnet is that the permanent magnet synchronous motor consisting of the magnets placed on the surface of its rotor, whereas in interior permanent magnet, the magnets are embedded inside your rotor so that the centrifugal force does not affect or does not damage the permanent magnet while the rotor is rotating, which happens into the PMSM type class of the motors. Okay, so shall I move ahead?
Yes, sir.
Yes,
No
sir.
problem.
When we speak for the brushless DC motors, the first thing should come in everyone's mind is that what exactly the brushless means. So the BLDC motors does not consisting of the brushes. So I'll go back here. The brushes which we have considered here are not present in the BLDC motor. The brushes present here in the DC motors are not present here in the BLDC. So how exactly the BLDC motor functions? How exactly? Sorry?
Sir, only 16 number slide is going on. I think BLDC motor, is it on a new slide?
Yeah, it is on the new slide. Just a second. Actually, my PC is not that much high performing. That's why. Is a 20 number slide visible?
Yes, now it is visible, sir.
Switch like this only. Only where the videos are there, we'll go into the presentation mode. That will be more good for you.
Okay, right now 21st slide is
Right.
visible.
I
20
got
and
the slide
21.
21.
That is visible right now.
Yeah. With brushed motor, which I explained previously on the 16 number of slide or 18 number of the slide, the brushes delivers the current through the commutator into the coils on the rotor. Okay. So, is this slide visible, sir?
Yes, working of DC motor slide is visible
Yeah.
right now. No, right, slide
Right.
number 18. That is
Right.
visible.
Right. Right. So, I'll just zoom in. Side. Okay. So, as I told, these brushes are delivering the power into your coil. That's how it is facing the electromagnetic force, and that is the reason your motor is running. Whereas when we consider the brushless DC motor, the BLDC motor does not have this blue component. That is the brushes of your vehicles. So how exactly they are communicating with each other, or how exactly the current is transmitting into your coil so that the motor keeps on running? It does not transmit in that way. Okay, because it doesn't, because the coils are not located on the rotor. The rotor is the permanent magnet, and the coils do not rotate, but instead are fixed into the place of the stator. So in BLDC motor, what we are doing is, see, this is the coil of your motor. Right now, in this DC motor, I am rotating the coil of my motor. Okay. So in BLDC motor, I will not be rotating this coil, but instead of, I will be rotating these magnets which are embedded into your rotor. Okay. So when we keep on rotating the magnets, the similar functions happens. Either we can rotate these magnets to perform this particular task, or we can rotate the coils. Okay. In BLDC motor, we don't use these brushes. That's why we have to rotate the magnets in order to perform the particular task of rotating or generating the power from your BLDC motor. Okay. Here you'll get the more couple of good idea. Okay. So I have not. Sorry for this video, guys. I have inserted the previous video only. So exactly this is how an DC motor works, but in BLDC motor, exactly the opposite things will be happening. So your stator is this, coils will be stationary, and your magnets will be rotating in clockwise or anti-clockwise direction based on the performance you will be needing. So if you wanted to move in forward direction, your motor will run in the clockwise direction. Similarly goes when we want to go into the reverse direction. That is when we try to take the reverse gear in your vehicle, the motor will rotate in the opposite direction. That is this, in the clockwise direction, your magnets will be rotating. Okay. Is this visible, sir? Highlights of the BLDC motor.
Yes,
Yes,
that is
very
visible.
good.
Right, slide number 21.
Yeah. So I think everyone must have understood the opposite direction which I told about this.
Uh, can I conclude that though it is a BLDC, still it is having a brush?
No, no, this is actually a wrong image I have inserted. It doesn't have the brushes. It uh, what happens now, sir? When we consider any motor, there are brushes
Hmm?
to continue the, allow the current to flow constantly into the rotor.
Hmm?
Okay. In BLDC motor, there are no brushes. I have inserted this wrong image, but
Hmm?
we can say that there are no brushes available here.
Hmm?
Okay, just a minute. Here the brushes are not present. This is a wrong image I have inserted by mistakes. I'm sorry for that. This positive and negative will be connected to the here only with the help of another concepts which we will see in the next slides. So the magnets will keeps on changing their polarity. So when I want it forward direction, my magnets will be rotating this, and this is my stator. It is having these field winding coils on which the coils are connected. So when my magnets are rotating, the current and the polarity gets reversed. whenever it is here. So for an example, in the next rotation, my north pole will be here and the south pole will be here. So that's how you experiences the rotation of your motor. Similarly, after another 180 degree or 90 degree, there will be south pole again here, and north pole will be again over here. Okay, okay, sir.
What is the basic advantage of changing this polarity, moving forward or in reverse direction?
Actually, sir, you have to definitely change the polarity if you need to produce the rotation of the motor. If you don't do those things, okay, I'll show you another one. Just a second, that you will get directly an idea. Okay. So, this is it visible, sir?
Yes, sir, it is visible.
Yeah, yeah,
Slide number 9 is visible.
yeah. It is visible. Okay. So, this is my rotor. This is my coil. Okay. So, if I don't give any other for performing its task, I have to complete this circuit, right? For an electric circuits to flow, all the circuits must be connected. So this is my power source. This is the positive side. This is the negative side. Okay. So when I am trying to allow the current to flow in this direction, the circuits get completed. That is the positive direction is going in this particular direction. This is my positive current is flowing in this direction, and my negative current is again flowing in back. So this is the current direction which it is following. Okay. So if I wanted to rotate my motor, I have to complete these circuits. Okay. So similarly, this is the more detailed encryptions which I have told. I think there might be a connectivity issue which that's why. Okay. So when I am delivering the positive direction, according to the Fleming's left hand rule, the force is acting in the upward direction. Okay. I'll do one thing. I'll explain it on my with my hands. Am I visible, sir? Hello.
Yes, Kaustubh.
Hello.
Yes, it is.
Yeah.
Slide number 10 is visible. It is visible.
No. Is my screen is visible too? I have started my camera to explain
Yeah.
how exactly the motor is performing.
Yes, yes,
Yes,
yes.
Kaustubh.
You are
So if,
visible.
Yes.
for an example, this is your coil, okay, into a rectangular shape. According to this Fleming's left-hand rule, I wanted to insert the force in this direction so that my coil will rotate like this. Okay. So if I wanted to rotate this coil, I have to give the current supply to these things so that my coil will experience this particular rotation movement, right? But if we keep on connecting only positive side to this, let's go back to the PPT now. Okay. Okay. So if I connect the wires directly here, if I connect my wire directly here, the wire will get fumbled with each other, or it will get
Hello, Kaustubh. Your
yeah.
cursor is not visible.
Is it now?
No, no, not yet.
Is my cursor visible?
No. Sir, can you see the cursor?
No, sir. It is not visible. No, sir.
Yeah.
Is it visible now?
Yes, yes, it is
Yes.
visible now.
Yeah.
Yeah, it is right now. It is visible.
Yeah. Okay. So what I was telling is that if we connect the positive wire to this coil, this end of the coil, and negative wire to this end of the coil. Okay, so whenever my motor will be my coil will be rotating in clockwise direction, that is my coil has to rotate in opposite direction to my magnetic field, that's only when my current will be generated. Okay, so I cannot connect these wires directly here, because if I connect those things, the wires will get crumpled with each other or jumbled with each other. Okay, that's why we uses another devices that is known as commutator. So do you understand this now, sir, why we are using brushes for transmitting and changing the polarity? Will be coming again over here, so it will give you an idea. So okay, so if I keep on giving the positive end to this particular direction, that is the pink one, okay, my coil will stop rotating after 90 degrees of its rotation. That's why I have to change the polarity, or either I have to change the position of these magnets. So if I place the north here and south here, the force will change its direction. That is, okay, sorry. Yeah, here when I am allowing the positive current to flow here in this coil, the upward force is there. Okay. The similar I have shown on with my phone, that when I wanted to turn my coil, I have to allow the positive current to flow in this direction and the negative current to be flowed outside of my circuit. Okay. Okay. After the 180 degrees of rotation, the position of this commutator changes. You can see the blue is now connected here to this brush. Sir, hello.
Yes, sir.
Okay. So that's why we have to change the polarity of the currents, or we can change the position of the magnets. That is the main reason we are doing those things. Okay. Should we go ahead?
Yes, Kaustubh.
Yeah. I hope you got that idea. Sorry for this that I have inserted the wrong images in the Bldc motor, which I explained current in the previous slide of the motor performance. This is in the same process. Only thing is that in this process, the magnet position of the magnets are changing. We are not changing the coil. We are not using brushes to change the polarity of the coils. We are just changing the polarity of the positions of the magnets. That's why we don't have to change the polarity here. Okay, it is directly getting changed because of the positions of the magnet. The magnetic, is this visible? Slide number 11. Anybody? Hello.
Yes, Kaustubh.
Yeah, okay. So as we can see, the direction of magnets are in this. The magnetic direction or the field of magnetization is from north to the south. If I change this, if I put the north here and south here, the field of magnetization will be from left to the right. Right now it is from right to the left. It will be from left to the right if I change the position of this magnet. Okay, so that's the basic idea behind how the BLDC motor runs. You only have to change the positions of the magnets, and it will directly changes the position of magnet. Due to the changing the position of the magnets, the field of magnetization changes its direction. Okay, that's how your rotor or your motor will rotate. Sorry, your motor will rotate, right? I have explained it here and written here also. It has only two major parts, rotor and the stator. Rotor is the part that moves the permanent magnet as rotor magnets. Okay, so these magnets will be rotating, not this one. This is a stator, which will be a stationary in BLDC motor. Electric currents through the stator winding generates magnetic field, which rotates the permanent magnets of the rotor. By varying the current flowing through the stator, the speed of motor can be varied. So I will be implementing my controller and I will be giving, okay, let's not go into that. Everyone must have driven a vehicle which consists of a gears. I'm not sure about the girls, but all the boys must have at least ride it once only. with the different. Everyone must have ride the motorcycles, right? Hello.
Hello?
No one's answering.
Students, we are expecting answer.
Yes, sir.
Yes, sir. Yes.
Thank you, sir. Thank you.
Please be interactive.
Yeah, please be interactive. Otherwise, it will be boring session for me instead of you also. I'll be getting more bored by delivering the session to you guys. Okay. Yeah.
Yes, sir.
Okay. So to change the speed of my motor, I also have different types of the gear arrangement here also. Similar to our IC engine, the motors can also be changed according to the gear. The performance of the motors will also enhances. If I am riding it on the gear number one, the speed of the my motor will be this. After gear number two, the speed of the my motor will be Y. Similarly, which we have experienced in an IC engine, electric motors are exactly the same. We just have to think it as an similar to an IC engine, because I have also, because I think you must have been getting little bit of a confused because of an electrical concepts and a mechanical concept. Don't be feeling don't have such feelings, because I came from a pure mechanical background. I have worked in an IC engine domains, and from that I have switched to an electric domain. This is not that much difficult. Okay, so this is certain things only if you have the basic knowledge you can understand the how exactly is motor running, because we have spent our almost 1 year or 2 years in this particular industry. It is easy to us, but I assure you all, if you have a little bit of an interest in this field, there is nothing wrong. If you can go, you can definitely achieve certain things being a mechanical engineer. Electric vehicles are your, what we can say, this is the right opportunity if you can grab to get the more knowledge about an electric vehicle, because the future of an electric vehicle is much more promising than an IC engine or SI engine. Okay. Okay. That's lots of a philosophy. We'll move ahead. Okay. So these are the certain advantages of a BLDC motor. Efficiency, as this motor can be controlled continuously even at the maximum rotational force. That is, at higher the torque, the performance of the motor will be more good in case of the BLDC. BLDC motors can be controlled using a feedback mechanism. It does not have to be changed its construction. This is the biggest advantage. Every two-wheeler manufacturers with whom I am working are still considering BLDC motors. They don't want to switch into the permanent magnet synchronous motors. Even though PMSM is much more reliable than BLDC, no one in the area or no one in the field is interested in work in the PMSM, because the BLDC motor is much more easier to control and it does not have to change its mechanism for all those things. It has the precision control, in turn reduces energy consumption and heat generation. The word precision controls depicts that the position of the magnets will be controlled much more easier than continuously changing the polarity by using the brushes. Because what happens with the brushes now, after certain periods, because the brushes are made up of carbon only, the carbon portion will keeps on deteriorating after certain periods of the time. That makes the traditional DC motor much more costlier to change all those brushes again and again, and it reduces the hassle to the consumers, to the suppliers, to the manufacturers, that they have to keep on changing the brushes again and again. That's the main reason BLDC motors are much more preferred in the applications like electric vehicle, because it is intact into a system. It is, let me remind you, it is also an IP67, the waterproof type of the motor. You don't have to think any other thing for when considering BLDC motor. You just have to give a throttle and go ahead into your journey. Okay, the BLDC motor does not get affected by the surrounding water conditions, road conditions, for example, air, dust, wind, water, etc., mud. All those things does not affect the performance of the BLDC motor. It offers high durability and low electrical noise. Electrical noise is similar to the noise which our IC engines keeps on generating with their silencers. The only difference is that the person will feel like he is Okay. Is anyone here drive an electric vehicle? It can be either two-wheeler, four-wheeler. Anyone? Or at least heard an electric vehicle passing by you?
Yes, sir. Yes.
Yeah. So when an electric vehicle passes from you, you must all have heard that the zoo sound from coming from it, right? So that is
Yes, sir.
exactly, yeah, that is exactly the electrical noise which every motors generate. Okay, that cannot be eliminated in any of the motors. We have to go with that only. Okay. This is the characteristics of the BLDC motor. As we can see, the starting torque of the BLDC motor is zero point 0.5, okay, Newton meter. That is good enough when considering the two-wheeler segments. These motors are precisely considered for 800 watt, 1200 watt, 1800 watt, and 3000 watts of the motors. Okay, the torque will definitely change according to the wattage of the motor. This is the speed ratio from high to the low, which I have taken out from Google only. You can do your research whenever you feel that much inspired accordingly. Okay, so as we can see, the starting torque for any kind of a BLDC motor is near about zero point 0.5 Newton meter, and it can use continuous torque for around 2000 revolution per minute. That is RPM. So for 2000 RPM, you are getting a constant zero point 0.5 Newton meters of the torque, and your torque after certain period does not drops to the zero, but it goes on decreasing, not that much decreased, only 0.28. That is near about zero point 0.3 or 0.2.5 or something, that torque is that much expected. But when we consider the lower speed, see here 0 to 80 revolutions per minute also, the torque is not reducing. That is the good thing which we can expect from any kind of the motors to have. Or even if the load changes, operation speed is still constant. Here you can see here the limited duty region, okay, and the continuous duty region. At the continuously load, for an example, if you are driving the electric vehicle constantly at the full throttle, even at full throttle, you will be getting 0.45 of Newton meter from the Vldc motor. This is the most, what we can say, efficient motor running performance Vldc motors can perform. So that is why Bldc motor is also preferred by all the two-wheelers uh, developers, we can say. Okay. In reality, Ather scooters are also using BLDC motor. So this is certain things which you should consider as a big. Ather is right now, I think, at number 3 when we are considering two-wheeler vehicles. Number 3 or number 2, I don't know currently, but they are very good. In the last couple of years, they have made a tremendous amount of an achievement into their
Ether
portfolio.
is Ether is holding third market share, sir. You're right.
Yeah, yeah.
One
Okay.
third.
Yeah. Thank you. Thank you. Okay. So the BLDC motors can be consisting of the two different arrangement. Either you can directly mount it on the vehicle. This is actually the flow. It is currently equipped into the Europe, and I don't know who is the dealer in India, or I don't even know that it is used in Indian market, or I don't know. So BLDC motors in used in the BLDC market. I'll tell you the local manufacturers of the two wheelers. That is the Miracle Motors, Green Shuttle, Easy Ride. They are also using the BLDC motors into with the hub motor arrangement systems. Okay. So, and Ather is using BLDC in runner type of the speed. This is similar to our IC engine. This is your motor. It gets connected with the help of the different gear ratios of the gears, and this power will be delivered with the help of chain or the belt to your vehicles wheel of the vehicles. Okay. Okay. Should we move ahead? Okay. This
Yes,
is,
sir.
yeah. Thank you. This is another type of the motor which is famously used. That is the permanent magnet synchronous motor. It consists of the magnets as a rotor. Here, this is your rotor. Okay. The middle portion, the blue one, is your rotor, and these are the magnets, the brown color one connected over the rotors. Okay. and these are the windings attached to your stator. So the working principle is same here. Either you can rotate the rotor or rotate your stator. Okay, if you are rotating your rotor, then the stator will be stationary, or when you are rotating your rotor will be stationary. You can do both the things in order to generate the power from any type of the motor. Okay, PMSM motor uses rotating rotor. That's why the permanent magnets are attached on the surface of the rotor. Okay, and the stator are kept stationary. With the help of the rotation of the rotor, the power we can expect the motor will be performing its task. Okay. The PMSM consists of a permanent magnet on a rotor and stator with a coil wound around it. The working of PMSM motor is quite similar to the BLDC motor. As I already told you, in BLDC, the magnets are rotating and the stator is stationary. Here also the same thing is happening. Only difference is that the stator is in the center, rotor is in the stator, and stator is covering the rotor. The difference in the BLDC motor is that stator will be in the center and the magnets will be around the outside of your motor. Okay, here is opposite direction. The magnets are in the center and the stators are on the outside of your wheel. Okay. This is because the change lies in the waveform of the back EMF, which is sinusoidal in the nature. The performance of PMSM is similar to the AC sine waves. That is the sine waves which we experience into the alternating current. If anyone has seen that, this is because the coils are wound on the stator in the sinusoidal matters. Just a minute. Okay. Is this visible to everyone? This graph?
No, sir, graph is not visible. PMSM slide is visible. Slide number 25.
Yeah, yeah. I am drawing the graph. Is it visible to you?
No, sir, yet it is not visible on the slide. I think it is taking time to load
Yeah, yeah.
your graph. I think that's it.
Is my screen visible, sir?
Yes, sir.
Yeah. Is the graph visible now?
Yes, now
Yes.
x-axis, y-axis, these things are visible now.
Yeah, yeah. Okay. Yeah. Thank you. So the sinusoidal waveform is just like this. Okay. And the normal waveform for a DC motor is like this. Okay. So the PMSM motor functions like this only. The one thing which we can we have achieved with the help of PMSM is that it performs similar to the AC motors, but it is not an AC motor. It is an DC motor only. It performs the same similar characteristics because all these windings are attached in similar way. The way it will be attached into the AC winding, AC motors. That's why BMS motors are good when performing at higher end. So for considering the vehicles like Tata Nexon, Tesla, another one like more bigger concepts that our buses, trucks, electric bus, they uses PMSM because it performs more well at higher speed. Okay. Advantages of PMSM is higher efficiency than PLDC motor. High torque, better performance, more reliable, less noisy. High performance in both high and low speed. Efficient dissipation of heat, reduced size of the motor. Now the question arises: if this motor is this good when comparing with BLDC, why aren't we using it instead of BLDC motor? The only thing is that the cost. With good things, you have to burden a lot of money when you are considering any type of a high-end performing device. Same thing goes with your laptops, your phones also. If you invest, not invest, if you spend almost 1 lakh rupees in an Apple iPhone, you will be experiencing good performance instead of purchasing that 10,000 of the phone. 10,000 rupees phone is also performing the same task, but only difference is that it will be delivering, its performance will reduce after a certain period of time. But the PMSM motor is to be considered or compared with an iPhone, it will be performing very well. This is the torque speed characteristics of an PMSM. We have considered 3 ampere and 6 amperes both kind of. Okay. So when we were thinking about BLDC motor, hello.
ए प्रत्यय त्याला फोन कर ना सुधीर रावाला
Om Shinde, please mute yourself.
Okay, it's okay.
सॉरी सर
Yeah, no problem. No problem. Okay. So when we were considering BLDC motor, the torque of the BLDC motor was zero point 0.5. Okay. For similar 3 ampere current rating. Whereas the torque of the PMSM motor is more than 1. We can consider this as a 2.25 or 2.7, near about 2.5 to 2.7. The torque of the PMSM motor is this much. Even at the lower speed ratio, even when we are considering 300 rotations only, the torque is this high. That means it has a lower start. Initially, the pickup, which we can say the pickup of the vehicle which is having PMSM motor will be high when compared with the BLDC motor. Okay. Similar thing goes if the current increases of the BLDC motor, current increases, the torque will goes on increasing. Okay. Should I move ahead?
Yes, sir.
Yes, sir. This is a basic difference of a BLDC motor and PMSM motor. Both of these motors are synchronous motor. Okay, so you can get a synchronous performance based on their characteristics for both of these motor. Okay, it is fed with the DC motor, pure DC motor, pure DC current. It is fed with the sinusoidal current. Okay, only two phases are possible. The phase is another thing. This is the phase. Okay, this is one phase. This is another phase. This is two phase. Okay, and when we consider three phase, this will be like this. This is three phase. So what is happening is that when we consider a 360-degree rotation, here you will be getting only two rotation for a 360-degree. Here you will be getting minimum three rotation. Okay, that is the major difference between the three phase and the single phase only. So when we consider the single phase, it functions on the voltage around 220 volts when considering a normal single phase, and when we are considering a normal three phase, it will be rotating. It will be functioning on 440 volts. The frequency in both the cases remains constant. The electrical frequency in India is 50 hertz only, whereas in US UK there is a 60 hertz. Okay, so BLDC motors has a high losses due to harmonic content. Has the less core losses, less switching losses while switching the speed or the gears from first, second, third. There will be a losses into the BLDC motor, but there are less losses in the BLDC motor, and there are more losses in BLDC motor. That's why BLDC motors are usually used with a much more or a higher grade of the vehicles. BLDC motors are easier to control even at the low speeds. We have seen that even at the higher speed, the BLDC motors perform similar characteristics. The torque does not get deflected or changed due to the speed of the vehicles or the speed of the motors, whereas cons- controlling PMSM motor at a higher speed or lower speed gets little bit of a complex. BLDC motors are suitable for lower speed. That's why two-wheeler manufacturers are using BLDC motor, because the maximum speed in the two-wheeler, normal two-wheeler, not the performance expected two-wheeler, is around 55 kilometers maximum. And when we consider the maximum performance bike, okay, for example, what is that bike? ODC Motors or Kabira Motors, when we consider, these are manufacturing their, or if anyone must have heard from the LinkedIn that ultraviolet motorsport is also there. They have made a huge difference into a performance bike sector. They have considered their vehicles and tested into different types of the area, like off-roading and urban driving conditioning, on the city riding conditioning. All those things have been considered into the ultraviolet motorsports. Go check their webpage or their LinkedIn page if you wanted to see how exactly an electric vehicles or electric bikes are performing around the globe. Okay, and let me remind, Ultraviolet Motors is not an outside; it's an Indian developers only. They have made a very good vehicles. BLDC motors are very noisy, whereas PMSM motors are less noisy. Okay. So this is this is one of my friend. His name is Hemang. Okay, he he manages, actually he owns a Northway Motorsport company in which they are developing retrofitments of an old Indian vehicles. So he has done the retrofitment of an Maruti 800, Maruti Swift Desires, Suzuki Ignis, Nexa Ignis, sorry, and different class. Yeah, even he has done Mahindra E-Verito also. Okay, so this is another example of a PMSM motor. This is the German-made cycles, which we can see in India also right now. They started selling in India also. They uses PMSM motors. Okay, so this is the battery pack which we can see here, and this is your vehicle. He has removed all the components from his vehicle. That is the engine, radiator, carburetor, all the things uh, which an traditional IC engine consists of. He has removed all those things and attached it with the hub motor, which is attached here on his wheels, and it is all-wheel drive system. That's why he has connected all the motors on the four of his wheels, and the batteries are supplying the power to it, and that's how a PMSM motor of his works. And this is a very good initiative he has taken up, and he has right now enlisted into the global magazines, Fortune magazine also, that the retrofitment kit from the Northway Motorsports has getting a huge amount of the response. Also, another tip: go check their webpage also if you wanted to see how exactly he is working. Okay.
Yes, sir. Basically, we are eager to know about it
Sorry.
because we are eager to know about it. What how this person is doing such a great job.
Yeah.
Recruitment.
Yeah. Yeah. Yeah, actually, he has returned from Germany. He has studied over there, all those things, and we have become friends recently only due to my allocations with the Ranjans Leon. That's why I know him very personally, and he has shared. Actually, we have also referred his notes during our post graduation projects, which Harshal and we have participated together.
Okay.
We have also designed a sedan class of a vehicle during our post graduation. Me and Harshal were we both were the project mates. So that's
Okay.
why we know Hemang very well, that how exactly he is doing retrofitments of an old vehicles.
Okay.
Okay.
Okay. Okay.
So this is interior permanent magnet motor. Okay. So, is this slide visible? PMSM?
Yes, sir, it is
Yeah.
visible.
So this is your rotor, okay, and this is the surface on which the magnets are connected, okay. What exactly happens in interior magnet now? The magnets are placed here, okay. So this is an advancement of a PMSM only. The embedded magnets into the rotor does not get affected due to the centrifugal force, and it gives more stability than surface magnet motors. So that's why, and so here it is, the interior permanent magnet. These are the magnets, okay. As a result of a continuous rotation of the rotor, after, okay, as it is a device, it will surely get affected after 10 years or 20 years. I don't want this to hamper my outside of this motor, okay. If I am placing magnets here, let's assume a worst case scenario that this bolt gets broken at continuous speed, continuous performance of never shutting down of this motor. This motor is keep on running for almost 5 years, 10 years, continuous works. What exactly happens is magnets will get the adhesion or the let's assume that these are connected with the help of bolts here, okay. Every magnet is connected with the help of bolts. What will happen? The life of bolt will get reduced after the 10 years. Definitely it will get reduced, isn't it? If this motor is continuously running, we are not giving it a break, or we are not allowing it to stop at certain period, or we are not allowing it to cool down for a certain period. It will definitely hamper now the life of this. There will be more wear and tear due to the continuous performance. That's why the interior permanent magnets have taken the birth. The engineers have given the birth to an interior permanent magnet systems, where the magnets are placed or embedded inside the rotor only. So even if this motor is experiencing wear and tear, this magnet will not damage the my stator. Even if the bolt will break down, the rotor will stop working, but the magnet will not get any other ends to damage my stator, which happens uh, sometimes into the surface mounted PMSM magnets motor. Okay. So these are the advantages of the PMSM. Mechanical safety is improved, as unlike in the surface permanent magnet, which I told you only. The magnet will not detach due to the centrifugal force. Okay. High torque is achieved by using the reluctance torque in addition to the magnetic torque. Same things with the PMSM. Only difference is that the mechanical safety in IPM has increased. That is the interior permanent magnet. Okay, it can respond smoothly at high speed motor rotation also. So you don't have to think about that it will be creating any jerk or all those things. But even at high speed also, you can travel much more smoothly and securely with the help of interior permanent magnet motors. It also consumes 30% less power when compared with the conventional surface permanent magnet motor. Okay. This is the comparison of an IPM and SPM. This is an interior, and this is the surface. See, what I was telling is that after 3500 RPM, this motor has stopped working. But when we consider that IPM, even at higher wattage, I am still getting the more number of motor RPMs. Okay, so that exactly explain how good is the interior permanent magnet design when considered with the surface permanent magnet motors. Okay, anyone is having any doubt or question?
For fabrication of campus utility vehicle, if we propose in Sanjivani campus, can we go for this IPN motor?
Actually, sir, it depends what type of the vehicles you are considering. Okay, I'll be getting in that areas also. If
Okay.
you are considering IPMs now, you can definitely go for an IPM, but you have to first identify that how exactly is the characteristics of your vehicle.
Okay.
Okay, for an example, what will be the driving cycles? I mean, how much your vehicle will be driven.
Okay.
Let's for an example, if you are driving only into the campus, not
Okay.
more than 10 kilometers, I assume.
Yeah.
right?
Okay. Yeah.
काय पाहिजे त्यांना आपलं मॅडम?
Okay. I think there's a background noise. It's okay. So those things also defines how exactly the motor is to be used for your vehicles. If you are only driving for that much 10 kilometers, only driving with the speed of 10 kilometers per hour, 25 kilometers per hour, then why should you go and invest this much of a amount in an IPM? Because
Okay.
IPM will definitely cost more when compared with cheaper alternative solution for these things, right?
Okay. Okay. Okay.
Yeah. See, investing in this much of a motor is not bad, but what is the purpose? I mean, if you are investing almost 50,000, 60,000 only in the motors,
Okay.
whereas you can get the complete conversion kit of your vehicles at around 75,000. Okay. For an example, we are associated with our one of the company sister organizations who has developed their EV conversion kits also for Tata S. Okay,
Okay.
that
Okay.
is cost nearly about 80,000. You will get complete package in that 80K. You will be getting controller, motor, all those things will be getting in that only. Whereas you
Okay.
will be getting only IPM at 50,000, 80,000. That is not the case.
Okay. Okay.
Yeah. You can get IBM. It's up to you only. You will be
Okay.
investing money. It's up to you what type of the motor you are needing. But
Okay.
IPMs are much more considered for higher performances.
Means need and performance. These two
Yes,
parameter will decide whether we should
exactly.
go for SPM or IPM. Okay.
Exactly, sir.
Okay. Okay.
Same thing is with the IC engine. If you are traveling from only college to your house, why would you need the 350cc bikes, 1000cc bikes, right?
Yes. 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 Yes.
That's the same
Correct.
case happening with the motors also.
Motors also.
Yeah, you can do very well with the 100cc Splendor.
Yes.
Okay,
Yes. Yes. Yes.
that's an
Yes.
example only.
Yes. 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 It's correct.
That's exactly the
100%.
how motors and the IC engines are similar to each other. I have
Yes.
to keep on reminding all of you that the IC engines and motors are similar because
Yeah.
we all came from the mechanical background, right?
Yes. 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 Yes.
Okay.
Yes. Okay.
This is a three-phase AC induction motor. It is also used in a the very big markets when we consider that the electric trucks, the AC induction motors are used because induction motors do not have high starting torques. Okay, so certain vehicles like the shuttles which we can see on the airports or in the company to company transportation, similar things which you said you need the vehicles for traveling into your campus, we can consider an three-phase AC induction motors. Okay, we can. Okay, the induction motors do not have the high starting torques like DC series motors, but this can be changed with an additional circuitry which is known as the field-oriented control. Okay, that's another concept which we can implement in this motor in order to develop the high starting torque. The only drawback of this motor is that it requires complex inverter circuit, which consists of a field-oriented control of the motor. Okay, but induction motors can be designed up to an efficiency of 90 to 95% also. So there are companies like Prevalence. Uh, other company is using this is let me see. I have added. Okay, yeah. Tata, Mahindra E-Verito is also using an induction motor. They have developed their FOC that is field-oriented control with an inverter circuit, in which they are using a three-phase AC induction motors. Okay, so these are the different types of the components which will be implemented in the induction motor. That and this is your laminated rotor core. Okay, all the rotor and its coils and windings are installed within this core, which is laminated with the help of a material so that it does not get affected by the surrounding components or losses. This is the laminated stator core. The stator is also laminated so that it does not get affected. Okay. These are the windings which will be wound all around your rotor. Okay, this is the output shaft through which you can connect your auxiliary devices or your wheels so that this motor will perform and deliver the power to your wheels. Okay. Other things like bearing, terminal box, motor terminal, this will be considering all the gear ratios for your motors. uh, Fan covers is used to cool down the state rotor so that continuously rotation wheel does not create much more of the heat and destroy the coils inside the motors. That's why the fans are also used in order to reduce the temperature. Okay, that's how an AC induction motors are constructed basically. Advantages of the AC induction motors is that their construction is very rigid. When we has anyone seen the Harley Davidson vehicles or Royal Enfield's engines? They are constructed very rigidly. Similarly, the AC induction motors, where the space with installing this motor requires a huge amount of the space, and the vehicles which are having this amount of the space is like trucks or your chota hathi, that is a Tata Ace, or any other type of the commercial vehicles which will be used for cargo purposes, which will be used for carrying out the much weighted loads on it. So at that cases AC induction motors are used. Okay, AC induction motors are also cheaper due to absence of the brushless commutator and the slip rings, which will be used in the Bldc motor, Pmsi motors, any other DC motors. When we consider say, switch reluctance motors, they all consist of all these brushes, commutator, and the slip rings. The maintenance of the AC induction motors is very low, unlike the DC motors or synchronous motor, due to the absence of brushes and commutator. And that's why the cost is also less and the maintenance is also less because all these three components are not present here. Okay. So what are the disadvantages of AC induction motor? Three-phase induction motors have poor starting torques. Therefore, these motors are not widely used. These motors are suitable only where the torque is to be like less than zero point 0.5 Newton meters. So in that application, AC induction motors are used so that you can travel. Okay, three-wheelers are generally using AC induction motors. Okay. We have a PIGO client associated with also. They are using AC. They are thinking about implementing an AC induction motors into their auto rickshaws. So we'll be expecting. We can expect all those things to be implemented from their end into the couple of the years. Okay. So they have more iron losses than any other motors, but even though they have all these disadvantages, the application as a low starting torque gives an edge for three-wheeler sectors when we consider an AC induction motor. Speed control of induction motors are difficult, definitely difficult, but as I told you, if we develop the field-oriented control circuit with an inverter circuit involved, all those things can be managed very well. Okay. This is the general activity I want everyone to perform. That the speed of rotating magnet is referred as the synchronous speed. Okay, so this is the speed of your rotation of the magnets or the rotor in which your magnets are embedded. Okay, this is the formula with which you can calculate the number of synchronous speed. Sorry. Okay, so when we consider 120 times the frequency, for an example, if it is a 4-pole stator, it will be having a 50 hertz. So 120 into 50 divided by the number of the poles, it is a 4-pole. That's the calculations which we have done. It is the 1500 rpm. Okay, the synchronous speed of an induction motor keeps on decreasing, the number of the pole increase. It is inversely proportional to each other. Okay, so when I increase or reduces my poles to the 2 only, my speed is 3000. When I am increasing my poles to the 4-pole motor, my speed is again reducing to the 1500, and I want you to calibrate for 600. Okay, so I'll give you 2 minutes. Do this calculation and let me know what exactly is the number for 6-pole motors and the 8-pole motors. So I can assume that everyone was I can assume everyone was paying attention to this from this point, and even if you don't calculate it, it's not an issue. But I think you should give it a try. Miss. I'll be back in a minute. Okay, so anyone from you guys have calculated it? Hello.
Hello, yes, anyone has tried it?
Okay, I'm not gonna tell the answers for it. You have to do it on your own only. Okay, we'll move ahead. Shall we? This is the Mahindra E Verito. It has only participated this year into an Delhi Expo of an EV Expo. E Verito. Mahindra's E Verito converted into an electric. It is also a very good vehicle. It has a low starting torque and all those things. Okay, let's move ahead. Okay, the major question.
Hello, Kostur.
Yeah.
One of the guy has Abhijit Randir has message on the chat that for 6 pole it will be 1000 and for 8 poles it will be 750.
Okay. Okay. Thank you, Abhijit. Thanks for giving it a try. Okay. For battery designing and thermal console software is used. Okay. Yeah. Yeah. Definitely. Ideal software for designing components of an EV. You can also design it on Tinkercad to start from the initial level to understand how exactly the things functions before going directly into the MATLAB or the Altair. You can definitely go into the MATLAB and the Altair. It needs all the derivatives and the mathematical portion from your background to be very much good enough. It's not that difficult if you are thinking to pursue a career into the MATLAB and Altair. That's very good thing, Abhijit. You should definitely give it a try. And for battery designing, thermal cooling console software is used. Yeah, there the console is used when we think about it to be compared with the real-time surroundings or giving it all the cooling or heating conditionings. The console is very good. It has a very good processing abilities, and it will render your data. The contour data will be much more rendered very easily. You can do the similar things with the help of an ANSYS Fluent also, but you will be needing a high-end laptops, and the ANSYS licensed copy is only needed for these things to do. Okay, so if you are considering a crack version, These things won't be possible in those things. We have we have designed the thermal cooling for our sedan class of vehicles during my post graduation with Herschel, and currently in my office also I have designed the thermal cooling arrangement for the battery pack of around 200 Ah, 72 volts. Okay, I cannot show you those datas because it's yes, sir. Now I am doing the internship in Katia. After that, I will try for. Yeah, yeah, definitely, definitely. Go for the Katia. Develop your designing skills initially, and later on go for this high-end performance performance softwares because this will be needing a very good designing skills. That's the main reason you should definitely focus on designing. Being a mechanical engineer, designing softwares are must to be apprehended.
And also for the student purpose, I will recommend that there is a courses on Altair University. So the
Yeah,
student can log in there and they can learn the Altair various softwares. And also on that basis, the certification basis, you can get the chances to do the internship from Altair also. So
exactly.
in detail, when I will visit the college, I will recommend Burkar sir to have the login to the Altair University, and we will have the collaboration with them. I have some university faculties. They are contact. Yeah, they are always in contact with us, and they will
Okay.
definitely help you.
Okay. Okay.
Exactly.
I am again one request that I'm in right now in admission duty. So for some of the minutes, if I will not be responsive, so please consider my
Sure,
presence.
sir, sure. No
And
problem.
Sure,
thanks to
sure,
Harshal
sir. I'm
sir.
there. Yeah.
Yeah, yeah.
Yeah, yeah, no
Thanks.
problem.
That definitely we will go for that Altair registration. A few minutes I have joined, so I have heard that about it. So in detail, I will discuss with respected Harshal sir.
Sure, sir, sure.
Yes.
No
Yes.
problem.
Okay, Kaustubh, we can continue.
Yeah. So, selection of an motor for an EV. It works in a when we consider the minimum number of considerations to be think about when all the what are the different types of consideration to be taken care of. These are the basically all these things which I explained initially to the sir also that he was interested while asking what type of the motor should be suitable for your campus. Okay, Sanjeevani's campus. So, vehicle characteristics, the size of the vehicles, weight, overload, aerodynamic drag. After that, uh, uh, gradient, wheel radius, all those things need to be considered while finalizing the motor for your vehicle. Okay. After that, the driving cycle, that is the it will be used for city to city travel or only in your cities. That is uh, urban driving, or the vehicle will be considered as the long road last mile connectivity vehicles, or it has to be used only for couple of minutes and then it is to be plugged in again for charging purpose. So that things also need to be considered. What will be the maximum speed of your vehicle, maximum torque of your vehicle, at what speed you want your vehicle to be run. So all these things needs to be considered when considering the motor, battery capacity, battery voltages. These things will definitely be changing point for your vehicle. That what capacity do, what range, what kilometers you are expecting your vehicle to travel. Okay, as I told you, based on the driving cycles only. If you are thinking that you need to travel only 40 kilometers in a day, so at that particular position, you don't need to have much more battery pack. You can go for the smaller voltages or smaller capacity battery packs. And on that only, when we consider the longer range, you have to consider the capacity of the vehicle. You capacity of the battery. Sorry, for the longer range, the capacity has to be increased, and for the higher performance, higher speed, the voltage has to be increased. Okay, so more the voltage will be, the higher will be your speed, and more the capacity will be, the longer will be your range. That's how the batteries and electric vehicles work. And definitely the cost is a At the end, everything matters at the cost. What cost you are trying to invest or spend onto the vehicles for what type of the category of the vehicle you are considering. It will be a commercial vehicle or low performance vehicle. Okay, that's how the motor has to be selected. Okay. This is the stability of the drive formulas on which the torque and other things needs to be considered. Okay, stability of drive. The load and the motor is connected to each other. As I told you, the motor is connected with the wheels. Wheels are nothing but the load of your vehicle. Okay, with each other. The load torque and the motor torque is given with the following equation. This is your motor torque. This is your motor. Actually, this is the motor torque, and J is the inertia with over the motor side. The inertia happening over the motor end is represented with the help of this J. It is a coefficient of inertia of the motor. Okay, and this is dynamic acceleration with respect to the change in time, and this is your load side of the torque. Okay, so there is M here. Okay, when we say motor torque is equal to the load torque, we can say the stability of drive is initially at stable level. When we see, when we can say this is greater, that is the motor torque is greater than the load torque. That means your motor is running at a higher speed. And inversely, when we see if the motor torque is less than the load torque, we can say your motor speed is reduced and your performance of the vehicle is very much reduced when considering all those things. Okay, so this gives the stability to your electric vehicles, and by stability, I don't mean that it needs to be run at a constant torque or constant speed, constant gear load. No, it has to be stable in driving. That is, it don't have to be creating much more jerks while driving of the vehicles. For an example, when the fuel of our vehicles get emptied, we can feel that there are certain jerks our vehicle is creating. That is that झटके मारती है बोलते हैं हम लोग गाड़ी कि अभी पेट्रोल खत्म होने वाला है हमारी गाड़ी अभी झटके मार रही है that thing has not to be that thing is not acceptable in electric vehicle systems. So the more will be your motor torque, the less will be the loads, and the less will be the load over the torque, and the jerks created by the motors will be much less. Okay. So this is the motor controller which you will be definitely needing if you are considering an electric vehicle. Okay. This is similar to the ECU. ECU not no VCU, vehicle control unit, which we used in the traditional IC cars. Uh, uh, all the electronic circuitry needs to be controlled with the help of this controller only into your vehicle. This is an electronic device. Motor controller is an electronics device that acts as an intermediate device between microcontroller and a power supply or a battery. See, microcontrollers are only used to tell at what speed which gear has to be uh, at what gear what speed has to be delivered to the wheels. That decision can only be taken by the microcontroller, but the speed and direction of the motor has to be controlled with the help of motor controller only. Okay, so if I have engaged my first gear, my motor controller will signal to my microcontroller that the this consumer or this user has activated the first gear, and we have to travel at 10 kilometers per hour, 20 kilometers per hour based on the gear ratio. Okay, so and this is a continuous process of motor controller and microcontroller. They perform very well with each other. That's why they are intermediate devices connected to each other in order for every electric vehicles. We usually call this as an ECU, electronic control unit, with in an electrical vehicles. Okay, so that's how the motor controller can provide the current at the required voltage, but cannot decide how fast the motor should turn. that decision has to be taken with the help of a microcontroller only. Okay, that's how the circuitry goes. So what? Choosing a motor controller. Motor controllers can only be chosen after you have selected your motors. I'll be showing you an example for Bldc motor controller only, but let's see how exactly the choosing of motor controller depends. It depends exactly on what type of the motors you are considering. For example, if you are considering Vldc motor, then you will be needing Vldc motor controller. If you are considering induction motor, then you need an induction motor controller, etc. This is a continuous process in which it has to be identified initially that what type of motor you are considering and what type of the controller is needed for your application. Okay, if you are considering two-wheeler, okay, two-wheeler vehicle, at that the size of the controller will be very small, whereas if you are considering a three-wheeler, four-wheeler, six-wheeler, heavy-duty vehicles, commercial vehicles, then the controller size will definitely changes with the size of the motors. So that's why I have mentioned here controllers can only be chosen after you have finalized what type of the motors you will be considering. Okay. The first thing any motor controller needs to be considered is that what will be the nominal voltage. Okay. So nominal voltage is the voltage which your motor will be needed to perform the task, and this voltage can be delivered only from in pure battery vehicles. This voltage will be delivered by the batteries, which we will be using as a energy source for our vehicles. Okay. Another consideration is the continuous current. So what will be my continuous current? For example, if I am having 60 volt 40 Ah battery pack, that means my continuous current will be 40 Ah. Okay. There are other terms like peak current. What will be the lower cutoff, lowest current? Okay. All those things will be increasing in, and will be considered when considering the motor controller. Controller method is another important consideration. Whether your controller is analog to digital or digital to analog, or it will be used for the constant signal only, or it will be used as a pulse width modulations. All those things are also to be considered for selecting the motor controller. Okay, should we move ahead? Anyone have any questions?
So can I say that motor, sorry, first of all battery, then motor, and then controller. At the time of selection, we have to consider these three parameters at the same time, simultaneously, so that there will be good performance. Because
Exactly.
peak current and whatever right now you said
Right.
the terminology, that are dependent on battery. A fully electric vehicle, not a hybrid vehicle. So in
Right,
that
right.
case, selection, when we do the calculation or selection procedure, then decide the three parameters simultaneously. भाई पहले हमें ये लेना है, इसके साथ ये लेना है, इसके साथ ये लेना है, तब जाके कहीं सिंक्रो होगा और जो परफॉर्मेंस होगा वो अच्छा होगा. So is it a correct?
Correct. Correct. But
Yes, sir.
initially,
Depending on the initially, depending on the battery capacity, we choose the motor specification and characteristics so that if you require the range of 100 kilometers for the mopeds, so it should provide that much amount of power from the battery, and the motor can run smoothly in that performance. So if you have implement the high end motor hub into that, then the motor will obviously drain the more battery power. So this way the battery can drain fastly, and you will get a less charge state of charge. That is the battery efficiency, vehicle efficiency.
Okay.
exactly.
And I think number of passengers, is it affecting the calculation? Because if I say I would like to make a six-seater open type of electric vehicle, a campus utility vehicle,
Okay.
and with the help, apart from the passenger, I would like to carry some other material. कॉलेज कैंपस में बहुत सारा मटेरियल यहाँ से वहाँ लेने जाता होता है,
Correct.
और समटाइम्स इट मे बी मूव टू वर्कशॉप or move workshop to college. So, can we consider the extreme weight, and is it affecting the calculation?
Exactly, sir. When we consider the weight now, the performance will be it will be varying. It will be a variable depending on your weight. मतलब अगर मैं 100 kg या 200 kg का व्हीकल डिजाइन कर रहा हूँ तो मेरा बैटरी बैक भी वो लेवल का चाहिए ना मुझे कॉन्स्टेंटली मतलब मुझे पता है मैं 100 kg का वेट कंसिडर करके चल रहा हूँ मेरी गाड़ी के अंदर
ओके
ओके तो मुझे पता है कि मुझे 50 किलोमीटर्स का रेंज चाहिए एट दैट पोजिशन आई विल बी नीडिंग मोर कैपेसिटी बैटरी दैट विल 200 Ah 300 Ah ओके तो आप जितना कैपेसिटी इंक्रीज करेंगे आपकी रेंज उतनी बढ़ेगी
अच्छा
ठीक है और सिर्फ कैपेसिटी बढ़ा के काम नहीं होगा आपका कंट्रोलर भी उतना सस्टेनेबल चाहिए मतलब आपके मोटर को वो उतना पावर डिलीवर कर सके
ओके ओके
ओके अभी रिसेंटली नाम नहीं लेना चाहिए बट ऐसे बहुत सारी कंपनीज है जिन्होंने ओवर द एंड बहुत अच्छी मोटर ली ओवर द एंड बहुत अच्छा उनका बैटरी बैक था लेकिन उनका कंट्रोलर ही बहुत वर्स्ट केस का था
ओके
कि गाड़ियाँ जल गई है सर
ओके
people are more afraid of purchasing electric vehicles because of such scenarios happening around the globe.
Sir, same scenario is happened with me also in the past. In the year 2017, I have lost a 3 lakh Swift Desire just by
Okay.
burning of the motor. So I will discuss on this matter later on.
Yeah,
But
definitely.
why I'm asking? Because when I increase the number of weight, means in our calculation we take the two parts: sprung mass, unsprung mass. So
Correct.
unsprung mass is a latter part, that is the for the low body masses, but sprung mass is an upward body masses.
Right.
So at the time of designing we always think that भाई 100 kg का एक आदमी बैठेगा ऐसे अगर 6 लोग बैठेंगे तो क्या होगा because if the car is to be used for the parents of the students and we cannot fix the weight their weight. Some are maybe of a heavy weight, some are maybe moderate, some may be low
Right.
weight, or don't consider the weight of the people, the luggage may be a very heavy weight also. So in that case how to go for the extreme case, but is it affecting and how to go for the formulation. So on that area right now we are working.
Yeah. Yeah, definitely it will be affecting your calculations because as you say, the weight and the other things, we cannot finalize those things. Those things are constantly changing and variable in nature.
Yes, 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 yes.
Yeah. So you have to consider a very good motor in that case.
Yes, yes, yes.
I must say you should go for a PMSM only
Okay,
because it
yes,
will be very good
okay, yes,
based on what you have requirements and the things you told me. PMSM motor will definitely be considered as a very good performing high end motor.
okay,
Okay. This is the okay. This is something which my company has developed. Okay, so here this is the four-speed gearbox Bldc motor, which we have developed for an Tata S. Okay, this is the conversion kit for Tata S. At first gear, will be expecting 15 kilometers of the range with a torque of 374.52 Newton mm. This is Newton. Okay, this is Newton meter. Sorry, not Newton mm. This is Newton meter. Okay. At second gear, this will be the calculations. At third gear, this will be the calculations. And at fourth gear, these will be the calculations for Tata S. Okay. So, sir, as you told me that vehicle needs to be carrying the luggage. So these are the calculations based on that only. My team has considered all the vehicle dynamics and its upspring mass, upsprung mass, all those gross weights of the vehicles, all those things has been calculated. And based on our customers' requirement, we have ended up at this particular calculations that we should consider that the gear ratio should be according to this. So we have our GUI softwares for all these things, BMS softwares to be implemented with the batteries because I basically performs more of my works at the battery end. So we have a vehicle design separate team. They have identified all these requirements and later on it has came to me that now we have to design the battery pack for this particular customers.
okay,
Okay.
okay,
So
okay.
this is exactly the scenario. If you are thinking for a vehicle at your campus, you can go with BLDC also. This will be much more your cost saving.
Yes.
The price of your vehicle will be much more reduced when
Reduced.
considering BLDC. Yeah,
Yes.
and
Reduced.
this is a 6 kilowatt motor for 6 kilowatt motor. This is. We also have another calculations for 15 kilowatts of the motor, which I have not included it because it is right now not in the state to be represented to the others. That's actually this is also I cannot share all those things, but I am sharing all those things with you guys. It's okay. This
Okay.
is a 6,000 watt auto motor. Okay. So the system voltage of this motor is 72 volt. As I told you, you have to identify what will be the volts of your motor. On that only you can identify how exactly your motor will perform. Okay. So this is your rated power. You can calculate this with the help of the AH and all those things. Okay, this is the peak power. The maximum the motor will deliver is 96 hundredths of the watt. That is 9.6 kilowatts, and the maximum speed is 3000 rpm. As I told you, BLDC motors are very good when considered up to 3000 rpms. They are very much uh, good at the controllability. They perform very well at 3000 rpms and lower rpms, less than 3000 rpms. This is the nominal torque. I mean, uh, even at no load, we can experience 19.11 Newton meters of the torque, and even at medium load, we can expect these torques. And at climbing the hills and all those things, let me tell you, we are also engaged with the three-wheeler electric vehicle developers. They are the green shutters. They are local electric vehicles developers. They are from Pune only, and they are involved with us for developing these all these calculations and all those things. So they are in the market for three wheelers. Their auto rickshaws are currently. Has anyone seen that electric auto rickshaw? ग्रीन कलर का होता है वो, छोटा सा होता है उसमें 6 people or 4 people are accommodated in that.
Yes, sir. Yes, sir. We are having that same in our
Yeah,
campus right now.
yeah. So the green shuttle,
But it is of a three-wheeler only, sir.
yeah,
So
it is
three-wheeler and
three-wheeler.
capacity is very small, and
Exactly.
that's why we are proposing a very uh, big capacity or somewhat a higher capacity. But
Okay.
I have seen the same in Club Mahindra campus. It's very good, white
Okay.
color, uh, very
Yeah, yeah, that's a golf cart, right?
yeah, like a
Yeah,
gold card, like
yeah.
a gold card.
That's my another customer. His name is Prevalence. They works in that category of the vehicle. So yesterday only I have designed their battery packs, or they have a different requirement this times. They needed a single battery pack, but in the two different boxes. So that's some certain things engineering in electric vehicles is developing day by day. That's how we are doing now. Okay, so these are all the things. The peak torque, that is the maximum torque your motor can deliver, and this is peak power to the nominal power ratio, that is the 1.6. This can be reduced also. If we reduce this, we can experience a much more range, according to me. Yeah. Yeah, exactly. If we reduce this to the 1.4 or 1.2, our vehicles range will increase because the AH will also be increased here. This is 83.33 nominal current they are requested. Okay, and the same battery can be used for delivering the 133 amp peak power or peak current we say. And this is the wheel diameter, that is 495 mm or 19 inches. 19 inches. Okay. So for your class of vehicles, sir, I recommend you should go with the 15 watt of the motors. Over speed 15 watt electric motor. This is the controller which I told you how to consider an electric controller. That my current reading here is 83 amp nominal. So I am having a controller for 100 amps DC. Okay. Okay, so the current rating peak, so 160 amps it can deliver for 20 seconds. That means for 20 seconds, we can expect that the current will be approximate 160, or their requirement is almost 134 amps. Okay, approximately. So this controller can surely run very well at 160 amps. It's upper end. We can definitely go with this. So the weight of this controller is only 2.36. I mean, only the controller can weighing this much, and the motor will definitely weigh a lot of. Okay, so working temperature is minus 40 to 100 degrees Celsius. This is some things which we can control with the help of passive cooling system or thermal management systems of your vehicles. That is by implementing radiator cooling channels, or same things which we do in the heat exchangers. We use as the counter flow heat exchanging material, or parallel flow heat exchanging material, right? Being a mechanical student, have you learned those things in your thermal? Hello?
Yes, a little bit things we have done.
Okay, the work control signal unit. This controller can be used for 24 volts from 24 volts to 72 volts. Okay, so there are different types of the motors also, like 24 volts, 48 volts, 51 volts, 60 volts, 72 volts. This controller can be used in all those range of the vehicle, so it is good enough to be considered. Okay, the feedback system is the Hall effect sensors, which can be used in order to keep on implementing and changing our reducing the errors of the systems, and keeps on improving continuously. The efficiency of your motor, this controller is 99%, and this is AIS standardized. ARAI regulatedly, ARAI body has approved this with a certificate of AIS standard 508408. So this controller is very good. Depending upon its efficiency, they have tested it almost 5 to 6 months continuous testing has been done in ARAI. After that, only we have ended up for this at 99% of efficiency. Okay. The standby power is less than 3 volt. So even if you are stopping at a signals, or stopping the vehicle for a particular person to get in and get out of your vehicles, the power consumed by your controller is less than 3 volt. Okay. There are also CAN communication ports. We can connect this with the help of Bluetooth, or can to showcase the display over your dashboard, where you can identify how much range you can expect to travel, what is the state of charge, I mean the battery percentage available, where is the next charging station available in, all those things. The telematics controller system, basically we can say the communication ports can be used with these controllers to showcase what are the different aspects of your vehicle is currently. Protection class is waterproof, completely waterproof, IP66 it is. Input protection, it includes the fuses on the case of 150 amp. If my motor is discharging more currents, more than 150 amps, the controller will initially cut with the help of the fuse. Okay. The reference port speed is with the help of throttle or potentiometer control. Potentiometer is a device which can be used in order to reduce the voltages. Okay, so that if you reduce the voltage, it is exactly the throttle only. If we release the throttle, our speed get reduced. Similarly with the potentiometer control, if you reduce the potentiometer control, your speed will be reduced. And it consists of, this is the dimension details, which is not that much important right now, because yeah, let it be. This is the temperature sensor. It consists of heat sinks temperature and motor temperature sensing. Heat sinks are implemented on the motors. That is the fins only, which can be used for air cooling of the motor. And motor temperature sensors are used so that if your motor get heated up more than the set preset value, the controller will cut off so that your motor will does not get damaged. So these are also the basic things which you can consider for selecting your controller. Okay, should we move ahead? Or anyone is having any doubt?
Suppose the vehicle is moving on a track, Means I right now I'm just speaking about E Baha competition. In E Baha competition, on the track itself,
Okay.
for for every round, the motor was getting heated.
Okay.
That was so heated, means even many times it directly the vehicles directly
Right.
stopped for many times. Can
Right.
I know the reason why it was happened? Because our connections were good, motor was new, battery was of a very high strength. We have taken a much care, and that
Mhm.
PFMEA and etc. That all everything we have done, but still we could not find the reason that why the
Okay.
motor was so getting overheated.
Uh, Sir, in your case, I think the air to which the motor is not getting ample amount of the air, as
Hmm?
the in EBAHA is a performance competition, right?
Yeah,
At
yeah.
that you need a very high performing motors. Okay.
Okay, okay.
For that reason, this might be another reason that your motor is not that much rated, or the rating of your motor for the continuous is not this much. Okay. So either I can say, let's see this. Here is the 96 watt is the peak power.
Hmm,
If
hmm,
you are
hmm.
exceeding beyond this power, this motor will also start heating up. Okay. So for that only, this controller is having motor temperature sensing.
I think it
Similarly,
was.
in
I think it was a 2 kilowatt motor in
so
that
that
case,
is a very
because
small motor, sir.
small motor, because
Yeah,
we are fabricating it with the help of rule book only. We cannot exceed the rule book. And in
right,
rule book, it is said that 0.5 kilowatt to 2 kilowatt. That is
right.
only the range. Beyond that, you cannot do. And
So
that's why.
okay, if you have considered 2 kilowatt motor, have you considered any cooling arrangement for it?
No, nothing.
No.
That was not there.
So you are only considering that the motor will be cooled with the help of air,
Yeah, yes,
right?
yes.
The
Okay.
dynamic cooling only you have considered.
Okay.
So have you allowed any ports or ventilation ducts to that motor?
No,
Have you considered those things?
no, that was not
Okay.
there.
So I think for
Okay.
e-Baha, I think you have considered a go-kart, right? Or it was
No,
a
electric go-kart was a different
okay.
competition.
So
E-bike was a different.
sorry, you have considered that roll cage one. Okay.
Yeah,
Yeah.
yeah,
Yeah.
exactly.
So, so the certain things are there. Some motors does not perform well according to the loads also.
I
So
think not providing the ventilation duct and any other cooling media, I think that was the reason of it.
okay. Uh, I cannot say much more because I haven't seen the data sheet of
Okay.
that motor.
Okay,
So
okay, no problem, no
yeah,
problem. I came to know about right now that
yeah,
that might be one of the reasons why it get overheated, because we have not taken care of ventilation. We are
right.
just saying that it's a 2 kilowatt motor. It will not have a much effect of the temperature. But suddenly on the track that was happening, and
No,
we
because
were not ready for that. So
yeah,
that's
because at Bahana, the your driver is not going to release the throttle because he has to win the particular competition, right?
yeah, yes,
So
yes,
what
yes,
happens that motor is constantly running at that particular higher torque. Okay, the peak power is continuous 96 watt,
yes.
9600 watts. Let's consider this as an example.
Okay.
So even though we are giving a peak power of 9600 watts, we are still recommending customers to not go at a full throttle. Okay, it will definitely hit if you are going at a 2 kilowatt at a constant 2 kilowatt power you are extracting from that particular device. It will definitely keeps on hitting, sir. You have to definitely consider a cooling arrangement for it, or else you have to give it at least a pins or proper pins, or you can do one thing, you can also implement the face changing material also there, so that it will not take up that. I don't think that the rule book of a Baha is recommending to use a face changing material or not, but yeah, if you are considering an electric vehicle, you
Yeah.
can think of all those things.
Okay.
Because I haven't participated in the Baha, so I don't
Okay.
know
Okay.
much of the rules of the Baha.
Okay. Okay. No problem, sir. But I get the idea.
Yeah, yeah, definitely.
Okay.
So this was the controller specifications. This is a regenerative braking. This is an Another key parameters for electric vehicles success rate if we are considering a regenerative braking. Okay, it is a form of braking in which the kinetic energy of motor is returned to the power supply of the system. Okay, for example, you are at this road conditioning. Okay, and you are currently at here and you wanted to go down. Okay, for this instant, if you goes rolling downward with a full throttle, you are just speeding up your vehicle. But if you release the throttle here only and start implementing the brakes, and the motor will keeps on rotating in the reverse direction at that particular motion, the kinetic energy turns the motor shaft in the reverse direction, and from this wheel you will be generating an electricity back into your battery. Even the vehicles which we used at our company are having a regenerative brakings, but it is not that much efficient. It only generates at most 3% of an regenerative energy. But yes, this can be done with the help of a complex integrity which is implemented in Tesla. Tesla has using this regenerative braking. That's why Elon Musk can say that our vehicles can travel 340 kilometers, 400 kilometers. They are considering all the regenerative braking. The one, even if you have gained a certain amount of a speed. For example, you have attained a 80 kilometers of hour speed, 80 kilometers per hour, and then you don't need that particular speed. You pull up your leg from your throttle and let the motor run in the opposite direction. So your vehicle speed will also get reduced at that point, and also the motor will keep on running in the opposite directions and keep on generating the energy in your battery. That's how a regenerative braking basically works. Electrical energy is routed into the battery and stored again. Okay, but even if we consider the regenerative braking, we still be needing our uh, authentic and traditional braking system, that is the disc brakes or brake pads, considering because regenerative brakings are not that much efficient at certain rates. If any instant any person or any vehicles or any other thing came across your vehicle, you cannot completely rely on the regenerative braking. That is the disadvantage. Regenerative brakings are not that much people are not that much comfortable with regenerative braking. Okay, so but this is a key parameter when considering a range and increasing the range of your vehicle. This is the common examples of electric vehicles of 21st century. This is the Tesla. This is Tata model, Tata Nexon EV, and this is the Tata's charging stations, which they have developed with the help of KPIT. Yeah, KPITs are collaborated with Tata's also. KPIT has collaborating with BYD. All the buses in the Pune has been sanctioned only by KPIT's approval. They have developed the complete kit for the electric bus of Pune. PMPL, the one which we travel with green color bus. It's an complete white color bus, sorry, complete electric vehicle, completely approved by BYD. BYD is a Chinese company, uh, the world's biggest bus manufacturers in the electric sector is BYD. They are very good in all those things. They have also implemented the super capacitors in their vehicles at China, because for that also you have to change the complete electrical connectivity and connection points for getting charged to the super capacitor, so that their vehicles can charge. Super capacitor is a technology which can be charged within a seconds, and it can also be discharged within a seconds. So super capacitor cannot be used as a storage device. That's why super capacitor has a very limited usage. And but super capacitors are definitely a good if we develop a certain energy storage devices or the battery for a super capacitor. Super capacitors can be definitely used. It can give you around 400 or 500 kilometers of the range within a seconds of charging. Okay. This is Tesla's Roadster, which has developed around March 2008. The first vehicles of the Tesla is this Roadster. Its peak torque begins from 0 RPMs and stays powerful at 13,000 RPMs. Okay. Roadster, Tesla Roadster This makes the Tesla Roadster 6 times as efficient as the best sports cars when compared with Tata Nexon EV, producing the 1/10 of the pollution with a range of 220 miles. Okay, this is an e-box. This is basically sponsored by an Amazon. Jeff Bezos has initially invested in e-box. They are planning to implement this particular vehicle for delivering the orders or the packages which all of us orders are all of must have orders sometimes in our life. So e-box will be a pure electric vehicle. Okay, and this is a retrofitment. Okay, I'll share you one link. Actually, it is a General Motors Model 1, General Motors Model 1. Yeah, they are the first people who have commercialized after the failure from 1912 to 1940s. They are after the failure, General Motor has came up with the Model 1 of an EV, and they have started out EV again. The revolutionary movement for an electric vehicle came up across with the help of General Motors. Later on, the regulationary bodies have identified that their vehicles are not that much good, but people are very much convinced with their vehicles. So some of the vehicle, all the General Motors that electric vehicle Model 1 has been what we can say destroyed completely in order to protect their authenticity and the decision made by the regulatory body that these vehicles need not to be run on our roads. Some people are in oppose, and some people were in the favor of the electric vehicles. So, yeah. So e-box is also having the regenerative braking, lithium-ion batteries, and all the bells and whistles of a regular IC engine vehicle. This is a pure IC engine vehicles which was initially afterwards converted into the EV market. It is initially an IC engine, and it can be charged only in 2 hours. It has 30 minutes charge for 20 to 50 miles. You can just plug, eat your breakfast or dinner or lunch. Your vehicle is ready to go for 20 to 50 kilometers again, 20 to 50 miles again. Sorry. Yeah. So that's the end. I am about to end this session, but let me show you an example which we have developed during our bachelor's on a Tinkercad. So Abhijit, this is the uh, software which we were telling that okay. This is actually an electric blender which we can see. Is this visible to everyone? Hello, Abhijit. Anyone?
Yes, sir, visible.
Okay. This is actually a electric blender which uh, this is not a blender for it. We have designed this as an electric blender. It consists of the 4 switches. This is stop, this is low speed, medium speed, this is high speed. Okay. So this is my microcontroller, the one which I was telling you all. This is Arduino Uno. I think some of you must have worked on this also. And this is our battery supply, power supply. This is BJT transistors which are using. This is resistors, and these are the wiring connections which we have given it. Okay, so we can develop these things in the Tinkercad. This is actually an electric, not electric only. It is actually a good software developed by Autodesk. Autodesk has designed this so that if you want to design certain things, you can first configure it here and later on go for the prototyping. Okay. So here, if I start simulating, my Arduino has connected here. Okay. For an example, see it again. This connector is removed from the Arduino. Okay. Now that it is started, but my motor speed is 0 because I have not started it. Okay. So when I press this push button, the motor speed increases. Similarly goes with this button, but the motor speed will increase again, and it will try to attain higher at the third button. Okay, see the RPM has changed. Now the RPM has reduced. This is the lowest end and this is the stop. So similarly, all the two-wheelers of electric vehicles runs. They have the three-gear configuration systems to which they perform, on which they performs, and on that only they. This is actually a basic model for you to understand how exactly motor performs at different gear ratios. Okay, so this is a electric bicycle which consisting of the displays also, and these are the potentiometers which I told you initially for giving an acceleration. Okay, so when I start the simulation, my 7 segment will show a 0 1 display. Okay, this is actually a binary code system. Two symbols means that the second gear is started. That if I increase the throttle, um, okay, the RPM has reduced because I have reduced the gears over here. Yeah, I have to turn on this also. It is 0 now. Okay. So my both the 7 segments are showing 1 now because my all speed, 3 speed has been activated. If I reduce this, it's not working properly. Yeah, you can see the one light means that the first gear is activated. Right now the speed is 5000 RPMs, and if I increase it again, the RPMs are changing. The lights are also glowing. That is the third gear is activated now. Yeah. This is the full speed for both the ICs which I have used or unidentified. So that's exactly on electric vehicles. Anyone is having any doubt? These are my details. If anyone needed any kind of help or any understanding of an electric vehicle, you can contact me anytime. And I'm always welcome to assist you anytime. Thank you guys. Baurkar sir.
Yes, sir. Yes, sir.
Yeah.
Yes,
That's it sir from me.
I trust. Okay, no problem, sir.
Yeah.
Uh,
If
Thanks
any,
for
yeah,
sharing.
yeah, just a second, sir. If anyone is having any doubt, please ask me. Feel free to ask it.
Yes, yes. Now I am going to the same
Yeah,
part.
yeah, yeah.
Now I request each and every student, if you have any doubt regarding our motor unit and motor controller unit, then you can ask right now. Let me check the chat also. If you have any doubts, you can write down in chat box if it is not
Right.
possible for you to speak. Otherwise, you can write down in the chat box or you can directly unmute the device. Abhijit, Abhijit, any doubt or any other student? Deepak.
Saying no doubt. Tejas is also saying no doubt. So let's
No
assume
doubt, sir.
they have understood what I have told them. Okay.
But are you understanding everything what sir has explained was explaining? Deepak.
Yes, sir.
Okay. So again, I request to all students, if you have any doubt, you can mail directly to me. We will convey the message to respected Kaustubh sir or directly. Now I request Kaustubh sir, if they share their contact details to us, students can may directly contact to you also.
I'll post it in the chat box, sir.
Okay.
I have posted my personal number and personal email ID. You can contact me anytime. You can also message me on WhatsApp also. This is the same number. No problem.
Okay. 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 I'm writing it.
Yeah. Okay, brothers. Thank you, Abhijit.
Okay. So without wasting time, on behalf of Mechanical Department and Sanjeevani College, I am very much thankful to Kaustubh sir
Thank
for
you.
sharing this knowledge. Truly speaking, the beauty of the today's lecture is to selection of the motor, because as a part of fabrication of the electric vehicle, when we select the motor, next step is to select the sorry. Once we select the battery, next step is to select the motor, because both should be kept synchronous, and then only we can implement it into the vehicle.
No, you can go in the opposite direction also. Once you
Yeah.
finalize the motor requirement, later on you can also finalize all the batteries requirement
All
also.
the battery requirements. Yes, yes, yes.
That
And
way also.
accordingly, the importance of motor controller we understand today.
Exactly.
So that is very important. How to select the different types of motors. What is the importance of BLDC motors?
Right.
And if I just look at the different teams in Sanjeevani College, but not only in Sanjeevani, other engineering colleges also. Everybody is using BLDC motors only.
Right.
We have experienced its importance, but theoretically or other side we don't know that why it is used. Okay, we are using it, it is performing well, it's okay. But is there any other type of motor or any other type of battery or complete package so that we can implement it for other.
Sir, your last part I missed out because there was a noise in your background. Hello? Hello?
Thanks, म्हणायचं होतं ना ते गेलं. Hello. Hello, am I audible?
Yeah, sir. You are audible now.
Okay, sorry for a few minutes, for few seconds I lost the internet
Yeah,
connection.
yeah, no problem.
So I thankful to Kaustubh sir, respected Harshal sir, that they have shared this important knowledge to us. I hope the students are getting benefit of it. Once again, one more thing I would like to mention right now. Our respected HOD sir, Dr. S. Bhaskar sir, want to join the lecture, but because of some other important meeting, he couldn't join our today's session. So
Okay.
later on, it is my request to Kaustubh sir, if it is possible for them to visit the Sanjeevani campus, then it is very, we warmly welcome you in our campus, and so that we can deeply discuss the other issues also, which we could not cover in such kind of on this platform of Google Meet, because some discussions need a detailed discussion and a detailed timing also there, and a lot of mail or a lot of things need to be done. So the whole Harshal sir team, including Kaustubh sir, I request to visit the campus.
Sure, sir.
We will spend a lot of time together, and we getting a lot of knowledge from you. We get showered from your expertise, and not only we, then we can contact or we can have a good communication with the students also. So with the help of this, on behalf of Mechanical Department and Sanjeevani College, I am thankful to Kaustubh sir and Harshal sir also. because of some other important meeting, Harshal sir has left the meeting. So no problem. Thank you. Thank you to everybody, sir.
Thank you, sir. Thank you so much. Thank you all. Thank you for attending me.
Thank you. Thank you. Now I request every student, now you can leave the session, and thankful to the students also to attend the sessions and to write down the notes. And if you have any doubt later on, we can clarify. Okay.
Okay, sir.
Okay. With these
Okay, sir.
words,
I'll take your leave. Thank you,
okay.
guys.
Thank you.
Bye bye.
With these words, I also leave the meeting. Thank you. Thank you to all the students.